All right, let's begin. I'm very happy to be here. Special thanks to Anna for inviting me and for organizing this event. Um, I know it's a lot of work to host an event like that. I'm Alex. Let me actually, yeah, start the presentation. So I'm the founder and CEO of Luxant. It's a company that has been doing research and development in AI, especially in facial recognition area since 2005. Today I'm going to talk about probably the two most exciting things of our day is stable diffusion and large language models, especially those models that you can run on your own devices. So that's my plan. And the main idea of my work is to use a language model to generate prompts for stable diffusion because usually coming up with prompts that create good pictures is quite hard. So a natural question is whether large language models can help us with that. Stable diffusion is a text-to-image model, which means it takes in some prompts and generates a picture. And quite recently, a couple months ago, there was a new version of Stable Diffusion release called SDXL, which offers better quality and higher resolution. And my talk is going to be more hands-on, and I'm actually going to show you some code. First, how to use SDXL. It's actually very, very simple. If you are using can everyone see that? Okay. Yeah, so it's actually very simple if you are using Hugging Face diffusers. Do that. Yeah. So you basically just load the model and then specify prompt and then like what you want the image to have, and then negative prompt what you don't want to have in the image. The number of steps, which is the amount of iterations the algorithm does to generate your image, and you perform the inference. And I will switch to a terminal and run this script. Python. I hope it will work. Yeah, so we see that it loads the models and runs the inference. It is quite fast. It is an A100 GPU. So it took like about 3 or 4 seconds to generate it. And let's see what it has generated. So I asked it to generate a cat. Yeah, so this actually looks like a cat. right? Um, for all this process to be more easier, I created a simple. Yeah, I created a simple web app. For now, I'm going to ignore the header. Is the mic working? 1, 2, 3. Oh, yeah, I can hold it like that actually. All right, so this is a picture of a cat. Looks good, but nothing exciting. So as some of you probably aware, to generate really like exciting pictures, you quite often need to specify like a really long prompt with all the details of what you like want to have in the picture. Like you specify the visual style, the mood, the lighting, and so on. To help with that, people have invented styles. Okay. So style is basically which words you want unconditionally to add to the prompt. Now I've chosen the cinematic style, which kind of tells that we want a cinematic still with all those uh, adjectives, and we don't want it to be cartoon or ugly or deformed or whatever. So let's see how it works. I will generate a couple of them. So this was the original cat, and this looks a little more cinematic, or like this one. But still, there isn't much happening in the picture. It is just a cat. And when the user wants to generate a cat, probably they have a more complex picture in mind. And the question is, how can we help the user to come up with a more complex prompt? And the answer, the probable answer is maybe we can use Chat GPT for that. We will ask Chat GPT to generate a prompt for stable diffusion. And this is what I'm gonna do. I have a prompt which goes like this. This is the Open AI playground. So the prompt basically says that please help me generate like a very detailed visual description and include like background, lighting, or whatever. I'm sending this to OpenAI, and it comes up with like something which looks more like a stable diffusion prompt. Let's go ahead and try it a couple times. So each time you generate a picture, it's random. So I'm just generating a couple pictures to see what comes out. Yeah, so like we see, the prompt said it's a black cat, it's sleepy, it's curled up, cozy bed, midnight. What else? Yarn ball. Yeah. So it has more content to it. On the other hand, we see that stable diffusion fails to recognize some of the words. Well, it recognizes, but it fails to take them into account. Like, I don't know, cozy bed, maybe it's there, but I don't know, silhouettes, starry night. I don't see like specifically starry night here. Okay, so to make this simpler, I added a magic button to the app, which is called Go Blur, which does the same thing. It calls OpenAI API and expands the prompt. So it will do the same. Yeah, so this cat has surely more content. We can try more abstract concepts like, I don't know, joy. So I will open two tabs. In one tab, I will generate images just using this one word. In the next tab, it will process them through chat GPT, and let's see what comes out. So this is the default behavior. Maybe it doesn't look like joy. I don't know. And this. Yeah. Yeah. To me, this looks a little more like joy. And chat GPT has come up with like you see, person jumping in the air, sunshine, balloons, confetti, and so on. So I think this way of expanding the prompt really works. The only problem is that first, GPT-4 is really expensive. It's about 20 times as expensive as GPT 3.5. And if you're creating a free web app, then it's gonna cost you a lot to use GPT-4. I tried using GPT 3.5 for the same thing, but the problem is that the 3.5 version, it doesn't really follow the instructions as good as the fourth version does. So, and natural, yeah, but that's one thing. The other thing is that GPT is kind of sanitized. So sometimes it thinks that the prompts you are giving it are offensive or like, I don't know, violent or whatever, and it just refuses to do anything. And yeah, so a natural question is, can we maybe train a local large language model which has less amount of parameters, but we will control it ourselves, and it will be cheaper, and it will generate whatever we want it to generate. So this is what I tried to do. So I fine-tuned Llama-like model to do the same task as GPT-4, and I'm going to show you how I did that. So actually, in the title, I said that I'll be using Llama 2, but in the last minute, I switched to a new model called Mistral. It has appeared like probably a week ago, but it's about 2 times more powerful compared to Llama. I don't know how they did this, but I chose this model. So to teach our small model do the same thing as the large chat GPT, we are going to do what is called distillation. So we will distill GPT-4 on our prompt, and we will fine-tune the smaller model. It's like the large chat GPT tries to teach the smaller model to behave in the same way as chat GPT does. For that, we need a data set. Usually, you can start with a data set of about 1,000 of examples. So in this case, the example is what we give to the to chat GPT, like the word joy, and what we get from chat GPT, like this long string. We assemble like 1,000 of those examples, and then we fine tune. We could probably come up with initial prompts like by hand, like, I don't know, take joy, fear, forest, river, like whatever. But it's easier to ask chat GPT to generate us all those initial prompts, which we will then like pass through chat GPT. And this is what I did. So I just used a very simple prompt, generate like several ideas for a picture. Each idea is exactly like either one word or two words or whatever. And sometimes the user may enter like a larger description. And in that case, I ask it to come up with like short stories of up to 150 words long. It cost me some money, but in the end, I'm gonna show you. Yeah, so I got all those ideas. Like you see, some of them are one word like canyon, island, whatever. Some two words, alpine lakes, city skyline, and they grow and grow and grow. And finally, there are stories like a magic pebble transformed a simple fisherman into a wealthy man overnight. It goes on and on. Then we put all those so-called ideas into chat GPT using like the same prompt, and get the result. So this is gonna be our data set. So the word sunset transformed into this prompt, forest into this prompt, and so on. And this is what we are going to train our language model on. There's another, like, a little technical but quite important question of how we will talk to the LLM. Do you want just to give it a single word and expect it to give us like this stable diffusion prompt, or are we going to ask it, write me a prompt, and so on and so on? Both ways could work, but I chose to stick with the first one. I will just give a single like word to the LLM, and because decoding the text takes time, and I want it to be as fast as possible. So my final data set, which I'm feeding into the LLM, is it looks like this. So each example is turned into a string of text. I invented some markup for that because it's better if like the question and the answer are separated. And the training itself is actually very, well, it's quite simple. So this is the script I used to train. It uses a thing called LoRa, which stands for low rank adaptation, and it allows to train this model really quickly. Because instead of updating all the 7 billion parameters, it kind of creates an add-on to this neural network and trains only this add-on. And it's really fast. So the whole script, it takes like about 5 minutes maybe to fine-tune this model. And after it is trained, another question is how are we going to use it on our server? So we need a tool which does the inference for us. And for inference, I chose llama.cpp. Some of you probably have heard of that. It's quite an efficient framework. It is very simple to convert the trained model into Llama CPP format. For those of you who are interested, like it's just several commands. And after that, llama.cpp will run on our server, and we'll just communicate with that. It is actually already running. Yeah, it's here. And there's a very simple script to talk to it. Like it's just sends an HTTP request. It sends the word cat. So let's run the script and see what it returns. Yeah, test. Yeah, so it returns black cat, sitting fluffy 4, yellow eye. So we can tell that the small language model, which we fine-tuned based on chat GPT answers, it really works. So let's finally see how it works. I'm gonna use the same app. I'll just make 3 tabs. Let's go ahead with the same words. So in the first tab, I use the prompt as is. The second tab, I'm using chat GPT to enhance the prompt. Yet on the third, I'm using Llama. To specify this, I need to use Llama. I just put an exclamation mark here. So this is our joy, like without any prompt enhancement. This is joy enhanced by chat GPT. And let's see how Llama works. I think it's probably not bad. Yeah, so as you can see, it came up with the same kind of prompts: sunny day, beach, playing children, ice cream, balloons, or whatever. Yeah, so probably it works, and we can try like other, I don't know, words. Like let's try horror. All right. Do you think it looks like horror?
Looks like joy.
Yeah. Well, maybe for stable diffusions, diffusion, both things are the same. And this is what Chat GPT has like expanded. Maybe, yeah. Yeah, it sure looks more like Blur. And let's see what Llama has. Huh. Yeah, it prefer. Yeah. Yeah, so it's a haunted house, full moon, spooky trees, or whatever. Maybe do you like maybe have any ideas of like what words to try?
Can we generate something for our meetup page? We need some content, like nice headliner. I have no idea. Curiosity. Curiosity. I like that.
Curiosity. Right. Um, curiosity. Curiosity. With Chat GPT and with Llama. Curiosity. Okay.
Let's go.
Oh, looks like joy. Wait, no, that's horror. That's curiosity.
For curiosity. Okay.
This actually looks like
Curiosity.
I like that.
yeah.
I like that.
Yeah, it's actually yeah. Yes. Let's see what's Chat GPT. It's a curious cat peering into mysterious box. Nice. This one. Same. Yeah, it kind of repeats itself. Curious cat begins in mysterious box. Curious child. Oh. Hmm. Yeah. Right. Well, let's see what Llama has generated. Oh, inquisitive child. Yeah. Huh. Cat, curious, injure, exploration, moonlight, cat, kind of. Oh, young child exploring nature, fireflies, cave. No. Right. Any other ideas? Or like we can move on to questions.
I have a question. Like, I'm wondering, is it because you have like child and cat in your training data? It tends to like do it for curiosity. It also has a lot of cats and
yeah,
child.
maybe we can actually look into that. Well, it actually could be the case that there was like the word curiosity in my training data. We're just like search curious. It's somewhere like there's this like kind of story, but I don't think like it was trained to produce anything specific for the word curiosity itself. Yeah, I don't know, like yeah, I think Chat GPT kind of associates curiosity with children and cats. Right?
Let's do adventure.
Oh, yeah, yeah. You can go ahead with the
training data. Since you have just like a list of words as a prompt, I think it's possible maybe to like training data enhancement.
Huh?
I think it's possible to do like training data enhancement if we just take the list of words and like drop some of them for the training data which is generated with the GPT-4. We have this good prompts with the GPT-4 and there is like 1,000 of them. Maybe we can do the enhancement with make the data set larger.
Oh, so you are talking about making the data set even larger. Is that? Yeah.
It's easy to do enhancement because there is so many different descriptions. If we drop 3 or 4 of them, it will still be a good profile.
Yeah.
It will be a little bit different. So maybe we can take, you take one, you drop 3 words randomly, and you get like 5 different choices, which is still very good, but you get the data set like 5 times larger.
Yeah. Thank you. It's actually a great idea on how to augment the data set without paying OpenAI too much.
Yeah, because was it enough like this size? Or 1,000?
I don't. Well, apparently for a task like this, it's enough because it turns out to be a really simple task. We don't ask it to do any reasoning. It just takes one word and like outputs semantically related words. So it seems easy. Maybe we can do better. Okay. Yeah.
I have 2 questions. First, actually, related to the data enhancement is how does the model sense to the orders of words? I mean, and I assume it does. There is some sort of like decay in importance, but does the model pick up the ordering of the output prompt as an important factor of the picture quality?
So which exactly model do you mean? The stable.
Yeah.
Oh yeah, the stable
the output of the Llama.
Well, stable diffusion is it's sometimes it's really hard to comprehend which words it picks, like how it selects what exactly to depict. I don't know. Probably there is some research like trying to find out like whether the position of the words really.
I guess like I think Llama can help to explain how like positioning and like the ordering and positioning of words can affect the output. And the other question: have you tried using just a Llama without fine tune on your sample? It's like the raw model and compare how much what the like uplift of.
Yeah, so you mean to use Llama without fine tuning, just listen. Yeah, it's actually a great question. It's like on my way to the meetup, I realized that I actually have never tried that. So I went straight to fine tuning because I couldn't comprehend that such a small model could be as good as Chat GPT-4 because Chat GPT 3.5 is considerably worse. So yeah, I think, well, I don't think it'll be good because like Chat GPT 3.5 doesn't do well. But yeah, it's certainly something that needs to be explored. But still, so the model here is fine-tuned to work without any like prompts asking it, like explaining what a stable diffusion prompt is. So we just put one word to that. So at least we save on tokens on the like processing thing. Yeah.
I have 2 questions. Firstly, so thank you for the talk. So basically, you're trying to Llama to generate stable diffusion forms, but Llama being open source, you're trying to outputs similar to GPT, which is more close. So can you replicate this process not just for stable diffusion, but for something? Because with regards to the other thing, Llama comes lower than GPT. So can you fine tune it for other purposes as well, rather than just for a single form?
Yes, of course. So do you mean like services like Mid Journey or DALI, or are you talking about something entirely different?
So comparison between Llama and GPT. So Llama being
Yeah.
lesser, so let's assume coding, with regards to coding, Llama would not generate the same or similarly accurate code as opposed to GPT. So
Oh, yeah.
fine tune that as well, or is it just for images?
Well, there are cases like I've read people do fine tune Llama. Sometimes it can perform even better than GPT-4, but this is in the case where like your task is really like I don't know, specific. For example, you want it to translate like I don't know Python into a language you yourself have invented. In that case, of course, GPT-4 knows nothing about that language, but you can, I'm sure you can fine-tune Llama if you get enough examples of how it works. So it really depends on the task. I think the tasks like translation, like in my case, we translate like a short prompt into a long prompt. It works. I think it will work with translating between languages like I know SQL, like natural language into a SQL query or whatever. But if you wanted to reason, I think probably GPT-4 is the best reasoner of the market until the guys will offer us something even more smart using their logical neural networks. But so far, I don't think that this small Llama model could beat GPT-4 in reasoning.
Second question would be September 25th, in ChatGPT will be going out 8 months backwards. That is what would be the right now it's short to long goes through ChatGPT. So that is not the case.
Like, do you mean that we take voice and generate a prompt, or?
So images can also be included in prompts. That is come up with ChatGPT. They will be rolling out the chemistry deciding for all
Yes,
users.
yes.
So in that case, what would be the fine-tuning case for your
Well, Llama cannot work with images. So there are some other models which can, but I am not too familiar with them. And another thing is that the language model inside Stable Diffusion is quite small. It's probably about 1 billion parameters. So this is the reason why Stable Diffusion sometimes has a hard time understanding like all the spatial relations between objects. Like if I want it to generate a bear holding a beer and riding an elephant on top of a turtle, like in the forest or something, it may generate individual objects, but it doesn't. I don't think it will catch all the relations. And I kind of suspect that that new DALI 3 thing, it maybe has GPT 3 or 4 inside it, so it catches those relations much better, but still it's close source.